Yeah, like Shannon said, my name's Norman No. I joined Core a little less than a year ago. I'm actually a structural engineer, but I like to dabble in parametric design and have a lot of fun with architects that also do parametric design. It's kind of a neat collaboration when both the structural engineer and the architect can be doing it at the same time. Um, a lot of that has to do with our TT tools that we have within Grasshopper. It kind of lends a unique perspective to parametric design, given a new suite of tools, especially when you're wanting to, visualize your data, understand your data. It's very important. So it's kind of what we're going to be focusing on today within Excel, using some custom TT tools within the TT toolbox. So let's just go through it. So like Shannon said, this is AIA accredited. I'm going to kind of stop here and just make sure that everyone has the software and plugins that are needed. We have some sample files I encourage you to download just so we're not recreating all the geometry, as well as the actual plugins. You need the plugins for the components. So I'm going to stop here and I'm going to ask for some verbal confirmation or maybe a thumbs up in the Spark, just to make sure I'm not turning along and everyone's behind me. And if you do have the plugins and we're just waiting, I encourage you to check out kind of a Swarm preview model. This is kind of a sneak peek at what Swarm can do on the web. It's actually the geometry that we're creating, or that has been created in Grasshopper, just in Swarm, so it's pretty neat. But yeah, if someone could give me like a all good thumbs up, ready to go. This is the Swarm preview model. All good. All right, I got one. I'll roll with it. All right, sweet. Good here. All right. This is kind of the outline that we're going to be going through. We'll start off with an introduction, talk about some basic Grasshopper concepts, what you need to know. This course is more lended towards more of an introductory level Grasshopper user. It's not super in depth. We're not doing crazy optimization or optioneering. We're not, doing Galapagos or anything like that. It's mainly just understanding the basics of Grasshopper, creating a model, and extracting some data from that model, and organizing it so that it's, visually pleasing within Rhino. And the main kind of tool that we'll be using is this Excel connection. We're able to stream data to Excel within Grasshopper using interoperability, and also modify the Excel sheet and kind of send data back to Rhino. So it's a multi-step process, but it's pretty unique, and you can create some interesting analyses. So we have our own suite of tools within the TT Toolbox. Those are the tools that I'm most comfortable with, but there are several different suites of tools. Lunchbox, GHXL, Bumblebee, like these all have kind of Excel interop tools that you can use. We're going to be focusing on the TT Toolbox, but it's worth mentioning that there's, like many things in Grasshopper, there's a lot of different ways to do things. Okay, so I'm going to ask that, we all have Rhino open, Grasshopper open, and there should be one of the sample files in here. Let's see. Excel data. You said AEC Tech 01 Excel data. So I'm going to go ahead and open Rhino. I just got rid of all of the kind of Excel portion of it. So this workshop file is broken up into 5 different parts. We have kind of the geometry, we have our sliders. This is how we're governing the geometry and how we're kind of creating a parametric model. And then we have our preview geometry, which is 2. We have kind of a custom geometric preview, as well as some colorization, etc. And then we have 3, which is kind of pulling data out from our geometry. 4, which is sending that data to Excel. And then 5, which is pulling data out from Excel and visualizing it within Rhino. So we're going to be focusing on 3, 4, and 5. If you have another project that you're working on, you have a cool tower that your company is using, feel free to use that. We're just going to be pulling data from the geometry, so you can use any model, any building. And as always, feel free to ask questions as I go through this. I know this kind of virtual AEC Tech kind of is like me talking to a computer for an hour or so, but during the real AEC Tech, I like to get to meet people and see other like minds within the industry. So feel free to shout out an idea or a question, or ping me or Han Chen. So before I jump into the workshop file, I'm going to go over some basic Grasshopper concepts. So first concept is series. So like if you want to kind of iterate over a number pattern, I remember this from like Algebra 1, where you have all these weird formulas that have, n in it, a summation of n plus I, and etc. It's kind of the same deal. Let me just like if you have step 1, count 6 times. So this is the series component. And with all these components, you can actually rename them line component. But what this is doing is, similarly with panels, you can get rid of the headers. This is multi-line data. This is a list. We'll be going over those as well. But this is just starting from an initial value and then stepping, however, kind of the number increment that we're stepping. This would be the I, the analogy that I created. And then the count, which is, the number of times that it's iterating over. So that's series. So this is nice. I like to do something like this when I'm kind of like thinking about like a truss. If you're making like 6 or 7 trusses and you want to kind of step them a set distance, it's kind of nice. And then next is range, which has to do with domain. So Grasshopper is kind of unique in how it sets a domain. So if we go to construct domain, not that one. Construct domain. It's actually just setting like kind of a set of number values from a start and end point, and then we can kind of manipulate that and kind of pull it evenly, pulling values out evenly over a set number of increments. So if I use this just for the time being, so 8 to 11. Oops. Then if I want to pull like a range out of a domain and I want a number of steps, so like if I do 3 steps for this, you'll end up with a list, 3 values, or 4 values with the start and end point obviously considered. It will let me grab it. So that is that's series and range. We have concept remapping. I'm not going to go over this too much just because I don't think we touch on it in this example, but it is a kind of a way that you can manipulate your data. Say that you have like this, the example of like an attractor field is good. So you have a set like number of circles surrounding kind of one set point, and you want to increase the diameter of a circle based off of its distance to that attractor point. You would use concept remapping. You can do similar things with like this rotation, time, color, etc. It's just a way to kind of reorder a list. But I don't want to spend too much time creating examples. I want to get to the Excel stuff. Next, very important concept is the concept of like a list and a tree. So a list is kind of just a set number of items. So, you know, when I create a panel, this is one set of items. If I go 4, 5, 6, 7, this is still one set of item. Like this is one index. If I right click and I go to multi-line data, you'll see at the top right corner we have this kind of this sign that it's turning into a list, or you know, Grasshopper users know it as like a branch. So for each kind of index within that branch, we can pull out data. And then a tree is kind of a series of branches. The important concept of a tree is that each branch can be of different length. So, you know, I'm a programmer. I like to call them lists of lists, but that's not like the flashiest of terms. So Grasshopper users usually correct me pretty quickly and tell me that it's a tree. And we'll be dealing with trees quite a bit during this example, so I'll make sure to touch on them. But you'll notice like this is 1, 2, 3, 4, 5, etc. And if we were able to split this list up into 3 different branches, you'll notice that the second branch is actually a different length than the first 2. So just an important distinction. Other important concepts are flatten and graft. If you flatten a tree, it turns into a list. You can simply flatten something by right-clicking on the input or output and you know, pressing flatten. You can also do Shift F. It's a neat little trick. And graft is doing the opposite. It's taking each index and turning it into its own individual branch. So instead of 0, 1, 2, 3, 4, 5, etc., this would be the first branch, the second branch, the third branch. And similar to flatten, you can Shift G on the inputs and outputs. Yeah, and that's kind of what it's showing right here. And there's also transpose. You can transpose a tree, and it's just like, you know, if you go back to your Algebra 2 days where you're flipping a matrix, that's all it's doing. It's converting the rows into columns. I don't think we'll be using this during this example, but just a neat little trick if you're manipulating data within Grasshopper. All right, now let's get into the fun part. Let's get into the workshop file. So we have, manipulate this. I have no previews on. Enable. I'm trying to see some of our geometry here. Those are the outlines of our floor plates. I believe we have some other geometry in here. This is our core. This. Enabled. Why is this not letting me preview? Oh, there it goes. Okay, so we have some floors and we have a core all set up with some sliders. Simple enough to manipulate the geometry. And the goal that we're kind of working towards is taking this geometry and adding it to Excel so that we can look at some data to make some decisions based off of the data. So I think during this example, we wanted to see, and I like to think of kind of how I want to format the Excel table before I even get into the Grasshopper definition, just so I know, how I want to set it up, how I want to organize my trees and my headers, etc. So I think we're doing number, floor height, or floor area, some area, and then floor heights. So we kind of want an Excel file that looks like this. And then we want the data to be added here. I'm going to add, or I'm going to leave an additional column at the beginning because we're going to actually just manually add a column and organize our data once we have the geometric kind of properties within Excel, so that we can kind of update the Rhino model based off of some manual inputs within Excel. But I think this is how we're going to create our Excel file. And you guys should see this TT Toolbox up here and this Excel components. So ping us if you don't see these. These are important for the demonstration. And we're going to be writing to Excel. So there's these two write options and write to Excel. I think it's pretty good practice just to kind of open up the components, see what the inputs are so we know how we want to organize our trees. So for the write to Excel, we have the kind of run button, which just takes a Boolean, typically a button like this. Excel worksheet, maybe you have some complicated Excel file. You can just specify the number of worksheets or the name of the worksheet. Obviously, make sure the string is matching. Column names or row names. So this is where we're going to put our headers. Takes a list. And then write options, which is obviously coming from this. Columns or rows, it's just simply a true or false. And then the data to write in the columns. It's important to note that when I hover over this, it says data to write into columns as tree. So we know that we're going to need a list for our column headers that looks like this. And then we're going to need a tree of length 4. And within each branch of that tree, we're going to need equal length kind of branches. So we have 22 values that we want to put into this column. We're going to need 22 for each one of them. So we're going to have a tree with 4 branches, each branch including a list of 22 items. So that's kind of how we want to format our data. So let's work on that first. So we want the number of floors. So we have, I believe these are the surfaces. Yeah, these are the surfaces. So these are actually our floors. We can just count the number of surfaces. I'm going to convert these to B-reps to begin with, just to clean up the geometry in case there's any like floating nulls or something like that. And then, we can basically count each floor as we're going up using the index within the list. So we know that like as we go up, our bottom floor is 0, 1, 2, 3, 4, 5, 6, so on. Now I think, I never know. Like architects always tell me that the ground floor is level 1, but in my structural Revit models, I always have the first floor being level 1. But we can go ahead and just add 1 to each one of these. So that our ground floor is level 1. We can always reverse the order of the list if for some reason they weren't in the correct order. And then we're going to convert this to a branch. Like I said, we have kind of 4 inputs or 4 outputs that we're looking for. So first one is this. We're going to convert kind of this list into a branch. So just using the flattened tree component. That's our floor number. And then we wanted floor area. So simple enough, area component on our surfaces. Geometry takes a B-rep or surface. Actually, it's probably better to do this. Gives us the area and the centroid. And then if we want to sum the areas as we go up, we can just use the mass addition component. So total area being the result, partial result being kind of the areas as you go up. So, this is, floor 1 plus the second index, and this is floor 1 plus floor 2. The third index is floor 2 plus floor 1 plus floor 3. So this kind of gives us the sum of areas as we move up the building. And then we can create branch number 1. What's next? Oh, we have sum of areas. Oh, we want just the individual floor area. Okay. So this is actually 2. The individual areas are just coming from the component. And then we want the floor heights. So we can just take the centroid of the area because it gives us the X, Y, and Z. We can just use the Z component. It's pretty simple. So we just oh wait, whoops, deconstruct. Just want the Z component. All right, we have 4 branches. Now we can just merge this, and this will be kind of our tree. Merge. You'll notice we have a tree. So going back to our kind of list versus tree, you'll see this is tree with 4 branches, all of equal length, which is important because, you know, in Excel, you want data in each cell within each row. And we have 4 headers. So it's a good start. Okay, so let's look at our write options. We have our data to send to Excel. Let's look at kind of the options that we can go with. So we have file path, we have clear data or overwrite. So this is pretty interesting. Do you want to clear the entire Excel file? Do you want to, you know, you could actually set up an Excel file with formulas and then send data to specific cells and then have the formulas, you know, perform some operation on those cells and then send the data back to Rhino. So that's something, but obviously if you're clearing the data in the entire worksheet, those formulas are going to be cleared. So just something to think about. You know, save after write. This is an interesting one to think about, like how the Excel file is going, how you want the Excel file to function. Do you want kind of a template Excel file that you're just reading data to or sending data to and then reading from? If you're doing it that way, then I suggest you not save it because you don't want to screw up that template file. You have close after write. I would only use close after write if you are saving kind of multiple Excel files. Say you're doing some parametric model or some optimization routine. You have Galapagos running, and each iteration you want to save to an Excel file and then close. This is a way you could do it. You could save after write, and then you could close after write. And then for each Galapagos iteration, you would have kind of a subset of data that you could look over. You could also not close after write. You could for each iteration write to a different row or a different column. And then simple stuff like column start position, row start position. And then there's a few fun, you know, conditional formatting colors you can work with. So let's start with the file path. Encourage people to use this and not writing their file path to a panel just because they don't have to worry about kind of formatting the double, you know, backslashes and all that good stuff. File path is a more robust way to do it. You can just select one existing file. I'm going to select this file, which I need to save somewhere. So I'm creating an Excel file and I'm saving it to a location, and it's going to open up this Excel file every single time. Now I can obviously change the file name every iteration by adding a 1, a 2, a 3, a 4. That's kind of how you would do that. Let's save it. Cool. We can close out. So set one existing file. Then just go to the location of the file. Perfect. Set up some Boolean toggles. Oops. There's default values set to each one of these. So, you know, if you just want to use the default, I believe it's false or true, false, false. You know, this is starting. If you don't put anything in column start and column row, it's just going to start at the top left corner. But just for robustness, this. So like I said before, we actually want to start on the second column because I'm going to be manually adding some stuff in the first column. So we're going to put this as 2. Row start position is 1. And then you can add colors if you like. I'm just going to keep it as is for now. Let me take our write options, send it over to the write to Excel component. So the Excel file that I just created only has one worksheet. So by default, it's just going to pick up the first worksheet in the entire Excel file. So we don't need to place anything in this input. For column names, this is what our column header is going to be. So let's go ahead and add these. Some areas for always right-click multi-line data. Columns are rows, so you can actually decide whether or not you want to input your data as a column or a row. Obviously, if you use rows, then each branch in the tree is going to be input into a single row. So, you know, I'm using columns, so I'm going to do false. It looks like by default it's true, so we need to change that. And then our data to write into the columns is right here. Quick little trick, if you see one of these lines, that means that you're sending a tree as an input. So if I flatten, you'll realize I'm sending a list, which, you know, you get this like double line. If you're sending a single input, then it's just one. Other interesting things, if you want to clean up your components, you can actually scroll in and remove parameters. But like I said, we want a tree for this one, so this is what we're sticking with. So what's going to happen when I press this? It's going to open up Excel, the file path that we gave the write options, and then it's going to write to Excel. So, I mean, it's pretty simple. Now, if we save after write, repress this. Oh. Open it up twice, once as a read-only. So you'll notice when I canceled out of it, it actually didn't ask me to save. That's because it's already, the most updated version has been saved. Oops, that's all right. So that's our Excel file saved. Now, if I clear all the data before I start, you'll notice it will open Excel. Everything will be cleared out of that worksheet. And then you'll see the data populate. But, you know, it happens pretty quick. Okay. I'm going to stop here. Are there any questions about writing to Excel? All clear. Nice. I'll be pretty honest, like, I don't know. I don't use the conditional formatting colors all that much, but you can play around with them. I know you can color swatch and add a 2 or 3. I'm an Ohio State grad, so I'm going to stick with some good colors here. Sorry if anyone's from Michigan. Like pattern your colors so that like your first column is red and then the second one is like a combination. It's pretty interesting. So I don't know the applicability too much with the colors. Hanshin, feel free to chime in if you have a neat little trick you use with the color swatch, but I haven't found too much use out of it. And if there's an error, like there's an issue with your write options, you can see it in the user messages. Also, if you don't want to use this component at all and you want to get kind of nifty with Grasshopper, or for some reason you can't use this component, you'll notice that it's actually just a formatted output of strings and colors. So, you know, all this is doing is formatting the data as this and then sending it to the right component. So it's important to understand like what Grasshopper is doing before you think of Grasshopper as a black box. It's actually just, you know, any kind of data manipulation software that's taking strings, integers, doubles, and kind of manipulating the data in a certain way. So this is just taking strings and sending it to another component. With that being said, we're going to write into the Excel file and kind of update our Rhino model based off of what we've manually input into the Excel file. So you'll need this read component. So we have run, file path, the read Excel sheet, the worksheet, and listen. So important to note, it's pretty simple to have the worksheet be the same input for both of these components if you do have a fairly large Excel file that you're working with. File path is the same, so we're going to be sending data to Excel. That's kind of like step one. And then it's a two-step process. So it's a little bit different than how Grasshopper users are used to things. Like they're used to kind of one steady flow, from start to finish. This is kind of a two-step process. You have to read to Excel, or you have to send data to Excel and then re-upload the data by reading from Excel. So we have run, file path, worksheet, listen. Listen's pretty cool. It's kind of a way to not make it a two-step process, so that, when you change something within Excel, it automatically updates Rhino. We'll go through some examples on that. We're going to leave it blank for now, but by default, it's false. Let's just do a panel. When I click this onto true, you'll notice we get our branches back. But each branch has the title in it now. So you have to do a little bit of manipulation and remove the first index of each branch. So what happens if we do this? It's going to tell me, could not find an open instance of Excel, or the file path is wrong. So a lot of times I get the question like, do I need to add the file path if it's already open on my computer? And yes, you do. So this is nice because, like, let's say you have 6 Excel files open on your computer. A lot of the times I have one to like calculate the beam capacity, and another one to do something else, and another one to manage my time. And I don't want to go into one of the random Excel files and start changing stuff. So that's why it takes the file path as an input. What I want to do is I want to take each floor and I'm going to assign kind of a property to it. I'm going to say it's like part of, office or hospital, or some type of amenity, and then I want to color by that amenity. So what I can do is I can type office, mechanical, kind of something like this. And when I come back in here, you'll realize like my panel hasn't updated, even though I have my Boolean set to true. It should be running, but basically there's nothing telling Rhino that it needs to recompute is the problem. So if I recompute, if I recompute, what's going to happen is it's going to rewrite all the data to Excel, and then it's going to pull out the same data. So that doesn't work either. So that's why listen is fairly important. If I set listen to true, bear with me, I have like 3 Excel files open. So this is what happens when I recompute. So basically I recomputed. So what it did was it opened another instance of the Excel file. It wrote to all the columns again, and then it read from that Excel file. So oh my, what's happening here? Is it because this is on? Yes, it is. Interesting. Okay, let's try this one more time. So we're going to write to the Excel file. It's automatically saved, and then read from the Excel file. And then we can toggle on listen. Hanshan, do you know why it's opening up this Excel file twice when I toggle listen on? Sorry, we're having.
I have no idea, but can you try just close both Excel and then turn listen to true again?
Okay, that's so interesting. Okay. It's not a live demo unless there's a bug, right? We're always learning. So interesting. Do I have multiple? No, I just have one. My file path set. Well, I guess we'll hold off on the listen for now. Right. Interesting. We're just going to modify Excel file. Okay, so ideally, like we would have this kind of constantly looking for updates from Excel so that we could in real time modify, some cells, and it would automatically change the values in Rhino. But for now, we're going to just toggle the run button from true to false. And you'll see that it's able to pick up the changes that I've made in the Excel file. So we now have this kind of like set of amenities for each floor. And what I want to do is I want to color each floor by the type of amenity. So this is, just a little bit of data manipulation. So we're going to pull a branch from this kind of tree. Simply use the tree branch. and we want to pull the first one, numero uno. What you're left with is kind of a list of our amenities. And then, as I mentioned before, we want to remove the first index of each one of these branches. So call index, call index. Now we're left with a nice set of amenities. So next up, we're going to create like a set. So a set is basically a way to isolate all unique values within a list. So this is nice because we're able to create a legend with the different values, and it will always pick up on, say we only have one type, then our set's only going to be one value. If we have 7 types, then our set's going to be 7 values. So it's an easy way to create an automated legend that has different colors associated with it. Set. We look at our set, we have 3 values. Nice. Because we have 3 values, I want my legend to have 3 colors. I'll give you guys a little challenge after this to automate the number of colors associated with the number of set, or a number of values in your set. It's kind of an interesting problem to have. As always, I'm going to pick the arguably the best colors. I'm only kidding. Three values, 3 colors. Pump them into color component. Nice. Now we can create a legend. 1 fish, 2 fish. Yeah, so this is quite nice because you have this legend. Red demonstrates mechanical, gray demonstrates office, green is hospital, and then all we have to do is map each one of these to the original list that we were given when we read the data from Excel. So going to, oops, not subset. I'm going to find the member index of a set. So basically, if we have a set with 3 values and we have a list with 20, 30, 40, this is able to show the index of each value in the list. So this gives us a pretty complex tree. So let's go ahead and flatten this tree. You'll notice we are left with indices 0, 1, 2, 1. So this is mechanical is 0, office is 1, hospital is 2, and then office is 1, 1, 1, 1. And then all we have to do is map this to our set, or to our color. So do a list item index. List item. So we are given a list, we are giving an index, and we want to return an item. So this is our list. This is our index. And we're left with a bunch of colors. Now all we have to do is map this to our original floors, and we're able to color the floors. So I'm gonna do this. Let's hide this, which I'm just using my scroll wheel, holding down, preview off. You can also right click. But we want to basically take this B-rep and color it. So we do a custom preview. Our material is our color. Our geometry is our B-rep. So another interesting wire. That you can use. Let's do this. You want to clean up some of your Grasshopper definitions. You can wire display hidden. So let's hide our original B-rep. What is this purple stuff? Ah, I remember now. Oh, that's the core. We want to keep that. So not the flashiest because our office is gray, but you can see that you can start to change the colors of the floors based off of the values that I placed in Excel. Kind of update. So that is how you would modify the Excel file and kind of send it back to Rhino. If you're making changes, you want to update stuff on the fly. You know, a lot of times in kind of the structural engineering field, we do a lot of designs within Excel, and we want to send it, you know, to some sort of platform to visualize. This is something we do quite a bit so that we're able to, you see overstressed beams within Excel, color them red, you can color, you know, the okay ones green. There's quite a bit that you can do with Excel. It just depends on how you set up your definition and you know, what your goal is within Grasshopper. So I think for the demonstration purposes, that was kind of the goal. I'm going to work more towards this listen component. But if there are any questions, I would encourage speak up now.
So with listen on, should it just auto read the Excel without having to save and re-toggle?
Exactly. So it's
Okay.
nice. It's like,
so that's how it was working for me.
it is working for you?
Yeah.
Or this is how it's working for you?
No, how it should be, where it's if listen's on, it auto updates based on what I input to Excel.
Nice. So it's only now working for the presenter. That's
Classic.
yeah, it's listen is important because the way Grasshopper works is it's like a continuous stream, you know, like you have to have the latest component hooked up to the one that you're trying to run. And because this is kind of starting by itself, like there's no input here on this left-hand side that is connected to any of these, right? There's no connection between these two. So there's no way for read or run to know that it needs to, you know, be performed again unless you recompute, which is just right click recompute. So, you know, listen is a way to like always have Excel or Rhino listening to Excel in the background. It's just another thing you need to realize about Grasshopper. If you unless you're using like Galapagos or Octopus or Calibri or something like that that's doing an iterative design for you, it's always going to only recompute the components that are hooked up, unless you right click and recompute. So, Anshan, did I miss any key points you want to add?
I don't think so.
All right. Well, I would encourage you to give it a shot, ask questions. Yeah, I think we have like 50 more minutes left, and part of these AEC Tech things are supposed to be, you know, walking around and trying new stuff. So we'll try and do that virtually. Does that work, Shannon?
Yeah. Sorry.
Okay.
I've got one other question. So say right now you have clear data / overwrite set to true, and you had manually input the office, mechanical, hospital, those type. That data you manually put into Excel. So say you like change the height or change the floor to floor height or something that was changing the actual geometry, and then reran the write to Excel, would that overwrite the data you had manually input? And if so, what's the best way to get around not having to re-input all that?
Good question. So yeah, because you're going to run into an issue where, like, let's say you add multiple floors. So your tree is going to be, instead of 13 indices, it's going to be 20, 30, 40, right?
Mm-hmm.
And you're going to be left with, you know, 14 components.
And I mean, realistically, if that was happening, you'd want to go. You would want to have to go in and reassign those, because if you're adding floors, that would probably be changing. But
yeah, I mean, you could.
I guess if you had the clear data overwrite off or set to false, would that type your column A, would that stay where it's at? Everything else would auto update. Then you just have to go in and refill out.
Yeah, I mean, you could have your Excel file be, you could save a template that looks like, oh, listen, it's really giving me issues. you could save your Excel file to look like this. Save as array, close as array, yeah. So that when I rerun it, you'll at least have the header and the types. But obviously, if you modify the inputs, like, so let's change our height and our floor to floor height. So now we're left with like a lot more floors.
Mm-hmm.
And if I rewrite, like, there's a lot more data. But at least you're left with the type, which is nice. The only other way to do it is you would have to add the data in. You'd have to do something similar to what I have with the number, and almost do a set, create a set, and then write it to the first column, and then change it manually.
Okay, yeah.
Anshan, do you have any other ideas? That's a no. The other thing I like to do is on this run component, you can actually do a button and a not gate. It's like a continuous, always reading. But if it gets stuck, you can just click the button and it's like a refresh button.
So what's that gate? You said not gate.
Gate not.
Gate not.
Yeah. So this is like a hack in Grasshopper if you want to create like a refresh button. If for something some process is getting hung up and you just want to recompute real quick. It's just like a quick recompute at this point. So if there are no other questions, Shannon, what should I do? Should I go into more stuff, or do you want me to show a little preview of Thread and Mirar and the programs, or what should I get into?
What does everybody else think? Any preferences?
Thread is quite nice because it actually takes a CSV as an input. So a lot of the times when we're doing like parent optioneering or something, we'll actually use the Excel function in Grasshopper to save our CSV files or Excel files, and then we import that Excel file into Thread, create some of the dashboards. I know Dave is going to be going over Calibri and wait, what is it? Calibri and something else?
Calibri and Thread.
Calibri and Thread tomorrow.
Mm-hmm.
I can show a little example of that. Hopefully I don't steal his thunder. But this is what, thread looks like. Like I said, it takes an Excel file to create one of these dashboards, but basically each one of these we call these parallel coordinates, but each one of these like lists on the parallel coordinates is a column in Excel. So, each data set is just a line. So we do this a lot of the times to like create optioneering analyses, understand like minimum steel tonnage for trusses, check out different midpoint heights, different panel points, different number of panel points. So I would highly encourage, check out the thread demonstration tomorrow. Dave is pretty awesome, and he goes in detail through all this stuff. We can see like in this example, we have steel tonnage on the right-hand side. And so we're able to go through and see like, what are the efficient designs? What are the inefficient designs? Say, obviously the high tonnage values are, look like this. This is something I would never want to see on a project personally. Or something like this. Small midpoint, high initial height, and very little panel points creates an inefficient truss. Whereas if you have, kind of evenly spaced panel points, and you start with a small initial height and a high midpoint height, you get a more efficient analysis. So very cool. There's a lot of stuff to go into with Thread. I'm still learning how to use it, but I would highly recommend it. Attending tomorrow, checking it out. Should I do next, Shannon?
How about we give everybody the chance to just like play around with it for the next like few minutes or so, like 15-ish minutes. Keep the Ring Central open, and then like as questions come up, we're still available to answer any of those, but kind of getting like free time right now. Or if you have any other tips and tricks, another example, etc.
I might just play around with it too.
Yeah, maybe you have a question.
All right, sounds good. Guess we'll all hang out virtually. Our lives now.
Very depressing.
Hi there, this is Junru. I have a question.
Yes.
Can you hear me?
Yes.
So I'm not that familiar with Grasshopper. I wanted to know what triggers Grasshopper to go through different options and write the data in Excel. Like which component triggers it to iterate through all the options?
It's a great question. So Grasshopper is not like an actual program. I mean, in a way it is, but one thing that visual programming struggles to do is create a for loop, which is like iterating throughout the definition multiple times. But if you attend the seminar tomorrow, they're going to be going over a cool suite of tools called Calibri, which allows you to do something like that. So you'll see you have your Calibri iterator, iteration, selection, some different parameters, and you can even save images. It's really cool. Highly suggest it. I use it a ton because at the end of the day, that's what you want to see. You want to see all the data in front of you. So
Right.
basically what it does is for each one of these inputs, right? It goes through and it if I double click, it will go through each individual kind of value. So like this is 0 to 1,000. It would go 1, 2, 3, 4, all the way to 1,000. But for height equals 1, it would go through each floor to floor height, and each width base, and each width top, and each depth base. So what you're left with is like millions of data points that you can write to Excel. And then, I suggest using Thread to visualize that data. That's how you end up with something that looks like this. And you'll see.
So other than parallel coordinates, is there any other tools that can be used to sort of view or explore the different design options?
Yeah, absolutely. So you actually create your own layout. Like I said, this just takes an Excel file, and then it's kind of up to the user. So whatever you want to do with it, you can actually just add the data table. Like if that's what you want to look at, then by all means go for it. And then it's as simple as saving it, and you can kind of look through. This is coloring by a certain value, and because I've selected a range of values, so I can kind of scroll through now and look at all my steel tonnages, my midpoint heights. But I can also add like a donut chart, or this thing is. There we go. Maybe in this donut chart, I want to go by midpoint height. And I want to select all the ones that have 13 feet as their midpoint height, 15 feet. Or I want to color by midpoint height. So like as like an SD level design, I think these are really important because you can show the owner like, hey, this is why we're making this decision. Like, this is how much money we're going to save you. Here's the data that backs it up. Here's our thought process. And also it's, people like pretty visuals, so pretty appealing to the eye. But you can do all sorts of stuff with Thread. I mean, I've done reports for architects to visualize different kind of concept designs. We did one on I think this was, we did one on an OSU project, which was, we wanted to visualize the steel framing, see the, this is actually coloring by the height of the members. So you can see like blue is, there's like small HSS tubes. But for the larger cantilevers, we had larger wide flanges, but it was kind of appealing because we had this kind of like curved profile from the front of the building. But yeah, you can do all sorts of stuff. This is just text. It's a very open platform, but it all kind of starts with Grasshopper and all starts with data. And I think Calibri is like a great start to that. If you're interested in doing iteration within Grasshopper, I think Calibri is your answer.
Very cool, thanks. I have another question. So, if in a parametric study you have like say 100 folders, and then in each folder you have a CSV file with the data that you're interested in, does Grasshopper has the feature to extract data from those 100 project folder paths to get this data and do some data manipulation for those data?
Well, I'm under the impression that Grasshopper can pretty much do anything. Crazy stuff. I think, yeah, that wouldn't be too bad using Calibri. You would have, let's do it.
I feel like in order for you to do that, you need a couple of things to be ready. First, you need to have all the paths to each individual CSV file, and then all the CSV file that you want to format should be pretty much have the same kind of column structure, I guess.
Yep.
Right.
So like if you had a folder and it was just 1, 2, 3, 4, 5, 6, 7, all the way to 100, right? That's what the folder name was.
Mm-hmm.
Like you could have a slider that was, 0 to 100, and then you could select like the first file path and then just add the strings together, and then Calibri to kind of iterate over each individual one.
And then I guess if your folder is like programmatically named, for example, if it's like C drive Windows folder, and then you just have 1, 2, 3, 4, 5, 6, or like ABCD stuff like that under that folder, then you can probably construct name parametrically in Grasshopper as well, so you don't have to manually type each individual folder structure out. You can just construct using like concatenation of string to construct that path and then feed it into this read file path component.
Yeah.
Right.
You doing some data mining over there? Is that what's going on? Bunch of CSV files. Move. Yeah, we're not. Oh. Remove the .xlsx. The split component, type split, cool. Oops. Wait, where do we get all these? We're writing them to one Excel file? Let's do a few of these. That's not like the parentheses. Whatever. That's so weird.
I think you can probably just use like a fixed parent folder path, and then only need to concat the folder name instead of breaking down all the like entire path.
I guess I could select a location instead of the file. Or can I? Select the directory. That works. This would just be. There way to remove the last this whole thing? Backslash.
You can break everything into chars and then just call the last index and then join them back together.
Okay. This is gonna bring it back together. Shannon, should I be doing any closing remarks here?
Nope. I'm actually gonna send. That reminds me. I'm gonna send the link for the survey. If anybody needs AIA credit, I've put it in the chat box. And let me actually send this a link to the playlist of where I'm putting all of the recordings as well. There's 2 up right now, but hopefully getting more up. Camtasia takes forever to render videos, so. But other than that, that's all.
Okay, cool. Yeah, I can also send you this Excel kind of iterator thing if you want to test it out in the Calibri.
Okay, cool. Thank you so much for spending the time on this.
Oh, it's fun. This is what I love to do. So, yeah, hopefully we'll see you guys tomorrow.
Okay, see ya.
Thanks, everyone.
Thank you.
Bye.
Bye.
Bye.